layer and then talk about the pragmatics layer that is a bit more interesting because it deals with more complex problems. So we talk about word sense design abbreviation. Next is NER or name entity recognition, which is also extremely important for many downstream tasks, especially polarity detection, because then you need NER for aspect extraction, like we'll discuss later. Here on the image on the right, you have also an ambiguity regarding a name entity, which is kiwi. Kiwi can be a fruit, can be an animal, or can be someone from New Zealand. So you also have ambiguities that need to be solved in NER. But if you work on this topic, which is again quite an interesting topic, and I have one PhD student, Joe Ran, who worked on this, and he did this his whole PhD only or solely on this. And there are a lot of data sets and works that you can look at. And also when it comes to NER, but also other tasks, as we'll see later, people also had to come up with some sort of annotation schemes to decide how to identify name entities in text. What are name entities? Again, they can be, traditionally, they were just names of places and people and and that's pretty much it. No, there was a third one, but I forgot what it is. But then later on, it got extended to many other different types. And here, this IO, BIO, and BROS are different schemes to identify name entities in text. Like when you are an annotator and you have to annotate text based on which name entities you find, and some are more or less fine-grained than others. For example, IO is the most general one where I just put an I for the parts of text that I think that they are a name entity, like Africa, reptiles, and West African crocodile. These other ones are more fine-grained because they tell me which parts of the name entity is a more general entity. So here, for example, in West African crocodile, we have some sort of three-nested entities. One is the crocodile, which is the most important part of the sentence. But then, which crocodile is it? Is it an African crocodile? Any African crocodile? No, the one from West Africa. So this BIOES is also useful for me to understand the subparts of name entities or nested name entities. And here we also display these in many different ways. Masking, which is what we discussed in lecture 2, was also very much used when encoder decoder models came about, and they were heavily used for name entity recognition. But then there are many different algorithms and different strategies that people have used, and it's still very much a research topic. Some people are using few shot, some zero shot name entity recognition, and as you can see here, it can be applied, it can be useful for so many downstream tasks, including sentiment analysis. Concept extraction is also one of those tasks that can be defined differently by different people. More generally, I would say concept extraction is about extracting keywords and multi-word expressions from text, but it's also about detecting those phrase verbs, like you have a lot of those in English, like you have here on the left, all the possible meanings that you can build on top of the verb get. But also it's about looking, not just zooming out, but also zooming in into, again, the root word or the lemma or the core meaning of a word on top of which you can build more multiple meanings based on adding suffixes or prefixes. So there are many things to consider here. As we mentioned earlier, with lemmatization, you may want to do some sort of normalization before you do concept extraction, like removal, stop word removal, or case folding. And but then the question is also of how, which list of stop words to choose. But then there are other issues, like we mentioned before, with the dot or hyphen or different spellings of the same word. So concept extraction is about extracting meaningful keywords and multi-word expressions, but also is about normalizing uh, word inflection so that you don't have duplicates basically in your dictionary or word embedding lists. And here is just an example, sample piece of code of how you can very easily, in one line of code, remove stop words from text. Is this always recommended? It depends. Here we are just importing a list of stop words from, once again, NLTK, but nobody tells me that this is the best stop word list for my specific application. Another thing that we didn't discuss much was tokenization, which is important for concept extraction. In English, it's very easy because you just have to split according to spaces to find tokens that then can also make up multi-word expressions. But in some other languages, you don't have this luxury, like in Chinese or Japanese that don't, or even Thai, which don't use spaces to separate tokens. Another important part of concept extraction, but also normalization in general. So here you also see that this could also be under the umbrella of the syntactic processing, is case folding. But this is specifically important for concept extraction because, as you know, many words can be referred to for different meanings depending also on the case that is used. So COD is different from COD, ARM versus ARM, AIDS versus AIDS, WHO versus WHO, and so on and so forth. So this is also something that is important for concept extraction. Here you have a few works and databases, but also knowledge bases for concepts, including, for example, ScientificNet, but also WordNet. That's the one that is mostly used for concept extraction, but also all the knowledge bases built on top of Wikipedia. And here on the book, you also find different ways for concept extraction, some more generative, more extractive structure, and for different domains like clinical domain and so on. Next, we have anaphora resolution, which is also very important for all those texts where you have a lot of pronouns like it, he, she, they. And here again, you can have something very simple as for example, just looking at whether some nouns in the previous part of the sentence are plural or singular or based on gender. So there are very simple algorithms that can do anaphora resolution literally with a few lines of code, but there are a lot of cases where things are not so easy to disambiguate. In some cases, you even need some common sense to know to which to which noun a pronoun refers to. So here you have some works initially by linguists, but then later on also by computer scientists using deep learning to perform anaphora resolution. And here you also have different data sets, benchmarks, and different approaches to anaphora resolution. Last bit of the semantics layer is subjectivity detection. We already discussed this the other day. Subjectivity can mean different things in different contexts. What I mean here is simply separating the objective text, which means either neutral or ambivalent, from the subjective one. So basically, subjective simply means either positive or negative. Why is this an important task? Because historically, many people realize that in most cases, you have a much higher accuracy if you do subjectivity detection first and then later on binary polarity classification rather than trying to straight away classify according to three classes: positive, negative, and neutral. Why? Because as we discussed in one of the lectures, it's in the past, most classifiers were optimized for two classes. They were binary classifiers, but also because in general, it's easier to like if you don't do this, you kind of force your classifier that maybe has been optimized for detecting something as positive or negative, and it's forced to also something that is neutral. It's forced to say that it's either positive or negative. So there's actually much to discuss here, because there's also the dimension of ambivalence, where you have contrasting opinions about the same opinion targets in a sentence. But this is something that I will discuss later when we talk about aspect extraction. So a lot of ambivalence can actually be resolved by aspect extraction, but nonetheless, it's good to do subjectivity detection before you do aspect extraction and sentiment analysis. So as you can imagine, this is a very specific task to polarity detection. And here, once again, you have some examples of data sets, not just textual, but also video and ASR data sets, and then also some knowledge bases that you can use for subjectivity detection. Here are some of the works, some more recent, like this by one of another Indian student of mine that applied SentiGNet to do subjectivity detection, Aparup Katwa. And then you also have Ranjan here, another student of mine, E.T. Chaturvedi, who applied deep learning for subjectivity detection. And if you are interested in more details, you can find them either in the book or by linking on one of these links that are some of our works. One more table about this is some more general techniques depending on different tasks. Okay, that concludes the semantics layer. Are there any questions? Okay, if not, I continue, then maybe you can have questions later. The last layer is a pragmatics layer, is the most interesting one because it deals with very complex and interesting tasks. Not that the previous ones are uninteresting, but still things like metaphor understanding, sarcasm detection, personality recognition are tasks that are very multidisciplinary and sometimes even cognitive inspired. And here, once again, you have a list of possible downstream tasks using some of the modules on this layer, but again, they are not mutually exclusive. And in fact, this is only based on some of the papers that we survey in the book, but actually you need many more. Like, for example, personality recognition, definitely it's useful for sentiment analysis as well as polarity detection. So this is just indicative of some of the papers that have been surveyed in the book. Metaphor understanding has been impossible to solve actually for many years because it's a very complex problem, because it's actually a two-phase problem. First, you have to individuate the metaphor, and then you have to kind of unfold it or explain it. But this is very useful because we use many more metaphors than we realize, even like in our daily communication, when you use phrases like "this is key to success," or "I need time to recharge my batteries," or even things like when you say that the market crashed. These are all metaphors, and they become part of our daily communication so much that we barely realize. But it's important for a text processing algorithm to also have a way to recognize and connect and map these metaphors so that they can be correctly classified. And here, once again, you have some literature. The first George Lakoff is the guru, considered the guru in metaphor detection. He's the one who initiated the whole literature. And then there are also some of our works. Ray Mao is one of my people in my group who's recently been focusing on using neurosymbolic AI for metaphor detection and understanding. And here, once again, you have more details in the book on where you can find available data sets and different algorithms for metaphor understanding, which once again can be useful in so many downstream tasks, including cognition analysis. And here we have a lot of papers recently on this, but also sentiment analysis. So metaphor actually is very useful for understanding how people perceive some topics sometimes in an unconscious manner, because when you do polarity detection, you're mostly looking at what people write and they are explicitly expressing their opinions. But metaphor understanding can actually be useful also to tap on the subconscious of people, because then it's not just about what they're saying, whether they like something or not, but it's also through the metaphors that they use that we can do some concept mapping to understand how they perceive specific concepts or products or services. So it's very interesting and very multidisciplinary task. We also worked a lot on sarcasm before. I also had a PhD student on this, Sojanya, who was working on sarcasm from text, but also from videos. Now he's an assistant professor in one of the universities here in Singapore. And here I also have a few examples of sarcasm, most recently multimodal sarcasm detection. And that's interesting because on top of detecting sarcasm in general in the communication, it's also very interesting to look at how different modalities can result in sarcasm when separately they are not. So if you take this piece of text alone or this image alone, per se, they don't have any sarcasm. It's only when you put them together that they become sarcastic. So it's also interesting to look at this kind of dynamics, and that's why multimodal sarcasm detection recently has become very popular. But even for text sarcasm detection, there are a lot of very interesting works. For example, we applied multitask learning for sarcasm detection. So we were looking at sarcasm plus polarity detection together in a multitask architecture. But there are also some other interesting studies that are not based on deep learning, but more on linguistic patterns. Like one interesting pattern that linguists found in the past was that most sarcastic comments are negative, and in all of them you see this shift from some positivity to some negativity at the end. So most sarcastic comments, if you realize, they are really like that. They start positively and then they end up negatively, and the final polarity of the sentence is negative too. So there's also this kind of interesting studies that you can look at. Personality recognition is also extremely interesting, and it's very related to personalization in AI, as we discussed yesterday. And there are here different models that people use. One that has been popular for many years is the Ocean or Big Five personality traits that classifies people based on whether they have active or inactive openness, conscientiousness, extraversion, agreeableness, or neuroticism. So this was quite kind of useful, especially the dimension of extraversion, because in sentiment analysis, the same concept can be positive for an extrovert but negative for an introvert, and vice versa. Recently, one other module that is more popular is MBTI, Myers-Briggs personality traits, which is maybe the one that you guys are more the know better. These are all those things that you can build like INTJ or ESFP and so on. But this is very nice because it's very modular. So you can potentially have a binary classifier for each of these dimensions. And so it can be very efficient, much more than Ocean. Ocean can also be binary because for each of these, you just have to decide whether it's up or down. But then this wasn't working too well for sentiment analysis because of the dimension of neuroticism. This was more for finding personality issues in clinical patients, but this is more general to understand the persona of a specific user group. So not just the personality, but also on a higher level, the persona, who is this person, what do they like? And this is also very much related to personalization in AI. So here in the slides or in the book, you have some more details on how these scores are, how these data sets are built. But then from a computational point of view, again, it's just a matter of having four good binary classifiers. Of course, this is also contextual, so people have used deep learning to do this more recently, but there are also some prior works that do not use deep learning and still can can classify, recognize personality traits quite well, both in text and also from videos. Next, we have aspect extraction. This is extremely important for sentiment analysis, but also for other downstream tasks. In other downstream tasks, maybe this is more related to topic modeling, understanding what the text is about. But in the context of sentiment analysis, this is extremely important to resolve ambivalence. So here, if you take this sentence, for example, and your goal is just to detect the polarity, you have some positive opinion and some negative ones. So what do you do with it? If you don't really have a smart way to handle this, you would just do an average, right? And that's when you have ambivalence, because this is it's neither positive or negative, or maybe you could say that it's negative because the negative sentiment comes after. But in reality, what you should do here is to do aspect extraction. So find what are the opinion targets, which in this case are touch screen and battery, and then assign a polarity to each of them. So this is extremely important thing to do for all those situations where you have multiple aspects. Even if they're talking about the same final opinion target, which is the iPhone in this case, you still have all these subset of aspects and features that it's important to take into account. First, to not to have ambiguity, and second, to have a much finer grain analysis of what your customer base likes and dislike. And this is also extremely useful for comparative analysis, because then if you have to compare different products, it's not very useful to say more people like this than that. It's so much more visual and insightful to have something like this, where you break down each product into a list of aspects, and then you can actually compare the opinions towards these aspects so that you can understand exactly why a specific user group likes this digital camera and why another that maybe has different habits and different purposes like the other one. So this is still something that people are working on, and there are so many ways that you can tackle this problem. You can just have the simplest way to do this would be to just have a list of aspects and find those in texts. But if you don't have the luxury of knowing a priori which ones are your aspects, then you have to come up with something different, like, for example, finding in a sentence where the polarities are going. So for example, one simple pattern could be that whenever you have the verb to be and then a positive or negative object, objective, whatever comes before that is possibly an aspect, because you are defining what is good or bad, and that's usually comes with an opinion target, right? But people more recently have been using deep learning for this, and on the book you find a lot of these data set and benchmarks. And again, to do the labeling, you can use the same annotation scheme that we were looking at before for name entity recognition. And here you also have some lexicon like ScientificNet, Probase, but also PrimeNet that we developed for aspect extraction. And here, once again, you have different also subtasks of aspect extraction. So in general, aspect extraction is what we call ABSA, aspect-based sentiment analysis, when you apply aspect extraction for polarity detection. But then there are also some other facets that look, for example, at aspect terms extraction versus aspect category. So here in our example, for example, we could say that touch screen and battery are the aspect terms, while iPhone is the aspect category, for example. So these are all useful definitions and useful works that help us to understand how to better perform fine-grained polarity detection. So last but not least, we have the downstream task, which in this case I put as polarity detection because that's what we do in our group. But once again, there is a long list of other downstream tasks, as we've seen in some of the past slides, like I don't like recommendation systems or summarization. Now I can't find the slide, but in many cases at the end of each task, we were talking about all the possible downstream tasks. Like here you have sentiment analysis, mental health, and dialogue systems, and so on. But in this case, we choose polarity detection because that's what we do in my group. And here, once again, you have some different approaches, some using lexicon, some are using pre-trained language models, some are using neurosymbolic AI, which we'll talk about in the next lecture tomorrow. And here you can also find very useful data sets and benchmark for polarity detection from text, but also from other modalities. And then polarity detection can be a downstream task that is serving another task itself, like I mentioned earlier. If you're doing financial forecasting or depression detection, human-robot interaction, recommender systems, polarity can be one part of your overall framework. Okay, that concludes actually already lecture 4, and I'm open to take any questions about it. Yes, Vivek.
Eric, that was actually a long list of papers to read, and I was really inspired to see that a comprehensive list. So I know that
Yeah,
some
sorry for
papers.
that. So I want to clarify once again that all these are things that we are doing in my group, but basically I have one person working on each of these tasks separately. And so each person is working for 3, 4 years, the whole of their PhD on these tasks. So I do not expect you guys to do all these things by yourselves. It's good that you know that these things exist so that you can have maybe a library that is doing that for you. But then, yeah, my recommendation is to choose to pick one and be focusing on just one or two of these, because otherwise, as you said, it's just too much papers to read and too much to absorb.
Yeah, I'm sure that reading all these papers would be a huge task, but I want to read your book word by word now.
Okay.
So I have a question, maybe because I'm willing to have your comments over that.
Mm,
Uh, Through this lecture, I learned that deep learning, if I use that name, they have significantly improved word sense disambiguation.
mm.
However, my question is related with the nuanced cases of polysemy and context dependent meaning. For instance, in the sentence, because you are there in Australia, and I wish to say, you gave me a long list of papers. Let's meet for a long coffee, although it's a long shot. So the word long shift from indicating quantity to duration to probability in the same sentence, like all three sentences if I group them together. Though some of the cases are quite unconventional. So how do DL models handle such subtle semantic shifts?
Yeah, thanks. This is a very interesting question because in the past, the way that these things were done is they were mostly just by firstly, they were just looking for, given a word that they know that has polysemy, find related words in the sentence from a dictionary. So I'm not explaining this well. There's this very simple algorithm called LESK algorithm, LESK, that does this. So it goes into WordNet and it finds a definition of the all the senses, and then it just looks for words that appear in the text that also appear in this definition to do the disambiguation. So this is a super simple way to do disambiguation, but also very good. I mean, it was very simple yet efficient in the past. Then all these things evolved into smarter ways to calculate these conditional probabilities by looking at the context. So, in the example that you gave, they realized if you have enough training data, you realize that whenever you have the pairing like long meeting, it's usually used in a negative way. And sometimes while when you have a long coffee, statistically it's positive. So it's just a matter of once again having probabilities, calculating a joint probability to understand whether the probability of this multi-word expression is higher to be positive or negative. One more interesting thing that we are doing is instead, and all these that I just mentioned are NLP approaches. An NLU approach to this problem is to understand, given an adjective like long, like also there are many others like big, small, what they are referring to, the quantity or the concept that they're referring to is what kind of concept, what kind of desirability this concept has, and also for which purpose. So if something is, for example, generally negative, then something that is already negative and you extend the duration of it and becomes longer, like a queue is negative, a long queue becomes even more negative. So you can think on these terms from a more like semiotic point of view. Your question becomes, what is it that becomes long? Let's see, what is this object? But then it's also a matter of context and purpose. So, for example, again, if you take the opposite of long is like short or small. So small again depends on what is small. As a small q can actually reverse the polarity of something that is negative. So q is negative, but small q becomes a positive concept. And but for many others, in some cases, you need even more than this by looking again at the purpose or the goal or the personal preferences of people. So if I say, for example, small room, maybe most people will not like to stay at a small room in a hotel, but maybe some people like it. So you also need to look at those nuances. Also, it depends finally on who you are and what you're doing. Because if you are the cleaner of that room, then you are happy that the room is small, because it will be faster for you to clean it. So there's a lot of things that can be done in word sense disambiguation, including making it interpretable and explainable, which again is what we did in the CentiGNet 8 paper. But then, yeah, you have all these layers, and it depends on where you want to stop and how much you want to go deep into the meaning. Because again, it can be as simple as counting co-occurrence frequencies to actually having a cognitive architecture that understand who, what, and why is working with a specific word sense in that context.
Okay, that was really helpful for me. I will look into this LESC paper and try to understand what it is talking about.
Yeah, the LESC algorithm is the most basic way you can do word sense disambiguation. But then, yeah, it's a starting point. Then you can look at all these other works that you have here. Oh, actually, it's just here on the on this slide. I didn't realize. So it's from 1986. You can imagine how old it is. But yeah, still worth taking a look. And then, but then after that, there are many other works that have been done, including some of our works on neurosymbolic AI for word sensitive, for explainable word sense disambiguation.
Okay, I appreciate it. Thank you for sharing it.
No problem. Any other questions from anyone else? So this lecture was more about NLP and slash NLU. So yeah, it depends on how you feel about it. This can be maybe too much for those like Vivek who want to go and read the details of everything. So in that case, you have to control yourself and just choose maybe one or two of these modules. But for some others of you who have always been working on NLP, maybe this all sounded a bit boring, but still, the takeaway here is that there are many NLP tasks, and there are many things that our mind is doing every time we are communicating or reading a piece of text. And it's important, I think, to have a module in your framework that is handling at least some of these tasks. Because once again, it's a mistake that to think that all these will just emerge automatically when I throw a lot of data. Some of this will in a certain way, but it's always safer and better to have this modular approach, because on top of uh, having less errors, also you can have once again more interpretability and explainability, and you can also do an ablation study when you have a framework like this. And last but not least, is also more cognitive inspired, because it's trying to do all these things that we automatically and almost unconsciously do every time we read text or communicate with each other. So if no more questions, I think we can stop here for today. We finished a bit earlier, but I know you guys have a tutorial next. So yeah, you can take maybe a slightly longer break, and then you can do the tutorials, and I'll see you tomorrow. So tomorrow, if you have more questions about this, I'm happy to discuss in case you had time to look at the book, or there are also some videos on our YouTube channel. So maybe the best way is to do that. You can just watch these short videos. Actually, the one work that I just mentioned on word sense disambiguation, we have a video of it shot by Shulang, my PhD student. So you can just watch that. Maybe it's more informative and more absorbable than going to read a lot of papers and read the book. But I leave it up to you, depending on mode you prefer more, and I'll see you tomorrow, and when we will conclude the course by talking about neurosymbolic AI, which is once again uh, it's our forte in my group. That's what we're doing mostly. We use state-of-the-art statistical methods together with more standard ways of like performing reasoning, like including logic, semiotics, but also semantic networks and knowledge graphs. We'll talk about this tomorrow. So I'll say bye for now and enjoy the rest of your day and see you tomorrow. Bye bye.
Bye bye. Thank you, Professor. Finish.